In the previous lecture, we discussed regarding freudenstein equation, where k1 cos theta cos phi minus k2 cos theta plus k3 is equal to cos theta minus phi. And if you want to find k1, then the equation is d by a, k2 is equal to d by c, and k3 is equal to a square minus b square plus c square plus d square upon 2ac. That we derived already in the previous lecture. Now, based on that, we have to solve today one example. Hmm. As I discussed earlier, that this is the equation k1 cos phi minus k2 cos theta plus k3 is equal to cos theta minus phi, and k1 is equal to d by a, k2 is equal to d by c, and k3 is equal to a square minus b square plus c square by 2ac. Okay. Now from this equation, we solve one example. Write down the data. Design a four-bar mechanism. Design a four-bar mechanism to coordinate the input and output angles as follows. Design a four-bar mechanism to coordinate the input and output angles as follows. Input angles is equal to 15 degree, 1 by 15 degree, 30 degree, and 45 degree, while output angles are 30 degree, 40 degree, and 55 degree. Okay, this is the data that is given to us. Now from this data, we are solve the equation. Before we solve the equation, we just from the data we just find that what is given angle. So theta 1 is equal to 15 degree, theta 2 is equal to 30 degree, theta 3 is equal to 45 degree from the data, and output angle is given to us. So phi 1 is equal to 30 degree, phi 2 is equal to 40 degree, and phi 3 is equal to 55 degree. Okay, this is given to us. Now we know the equation, the Freudenstein equation for the first position of input and outputting. Already we discussed that this is the equation k1 cos phi minus k2 cos theta plus k3 is equal to cos theta minus phi. Okay, so we are use this equation, and we have the first value where theta 1 is equal to 15 degree and phi 1 is equal to 30 degree. I am just talking about these two values. So theta and phi is given to us. So based on that, we are start to find the first value. We have the equation. I repeat the equation: k1 cos phi minus k2 cos theta plus k3 is equal to cos theta minus phi. Okay. Now we are just put the value of theta 1 and phi 1 in the equation. So we are getting k1 cos phi 1, so 30 cos 30 minus k2 cos 15 plus K3, okay, is equal to cos theta minus phi, means 15 minus 30. We know that cos 30, the value of cos 30 is 0.866. So 0.866 K1 minus 0.966, the value of cos 15, K2 plus K3 is equal to cos 15 minus 30. So if you get the value, if you want to find the value from the calculator, then the value is 0.966. 0.966. This is my equation 1. Okay. Remember this equation. We are use same equation for all three values, that is theta 1, theta 2, theta 3, phi 1, phi 2 and phi 3. Now similarly for the second position, we know that the what is second position, where theta 2 is equal to 30 degree and phi 2 is equal to 40 degree. Okay, so same equation. Once again, in place of theta we are put 30 degree, and phi in place of phi we are put 40 degree. So K1 cos 40 degree minus K2 cos 30 degree plus K3 is equal to cos 30 minus 40 degree. Okay, so if you find cos 40, then 0.766 K1 minus 0.866 K2 plus K3 is equal to cos 30 minus 40 cos minus 10. That answer we are getting directly from the calculator, that is 0.985. So this is the second equation. First equation, where theta and phi value is given to you. Just write down the angles theta and phi. So very easy to solve the example. You have to solve the value of K1, K2 and K3 after I just finish the value of K3. Third equation, now we are in third equation. So for third position, we know that theta 3 is equal to 45 degree and phi 3 is equal to 55 degree. Okay, so K1 cos 55, in place of phi we are put 55, minus K2 cos 45 degree plus K3 is equal to cos 45 minus 50. Cos 55, the value I am getting from the calculator, that is 0.714 K1 minus cos 45 0.707 K2 plus K3 is equal to cos 45 minus 55, so it is equal to cos minus 10. Already we are find that value in the first equation also, so same value here, that is 0.985. So we are put the value 0.985. This is equation number 3. Okay, now I mentioned all three equation at here, so very easy for you to solve the value of K1, K2 and K3. Give me the answer fast. 0.866 K1 minus 0.966 K2 plus K3 is equal to 0.966. This is our equation 1. Simultaneously 0.766 K1 minus 0.866 K2 plus K3 is equal to 0.985. This is our equation 2, and 0.571574 K1 minus 0.707 K2 plus K3 is equal to 0.985. Okay, give me the answer from these three equations. What is the value of K1, K2 and K3? Just find the value. Already you know that how to find the value. So then we just apply the remaining three formula in the value. Whatever you are getting the answer, just your answer provide me in the chat box. So we are going for further. Just find the answer of K1, K2 and K3, where 0.866 K1 minus, if I am getting the answer, then and then I am going for the next stage that is very important for us. So I just want answer from your side, the value of K1, K2 and K3. I also start to find the value of K1, K2 and K3. So let's check what is your answer and what is my answer. Please mention your answer in chat box. I just once again provide you three formula in the chat box. Okay, I share all the three formula in chat box. So you just start the find K1, K2 and K3, and then I go further for next step. This kind of examples are mostly asked in your exam, so you know that how to find the values, and it may not take more than 2 or 3 minutes. Find K1, K2, K3 fast. It will not take more than maximum 3 minutes. So provide me the values of K1, K2 and K3. These three values are very important to solve the example of Herbert mechanism with capital AB is equal to small a, capital BC is equal to small b, capital CD is equal to small c, and capital ED is equal to small d. As discussed in the previous slide. So just find the answers of K1, K2 and K3. It's very easy, and that kind of example definitely ask in your exam. So value of K1 0.905, value of K2, yes, it's 1.01, and value of K3, yes, it's a 1.158. Okay. Please compare your answer with answer provided by me. Otherwise, just solve the equation once again and find all three values. Now, I just mentioned all the three value that A1 is equal to 0.905 as mentioned earlier, K2 is equal to 101 and K3 is equal to 1.15. Now we have another equations that K1 is equal to D by A, K2 is equal to D by C, and K3 is equal to A square minus B square plus C square plus D square by 2S, as I repeat in the initial session of the lecture. Here, not a single value is given to us. So initially, the length of one link, here we consider small a, say A. Length of one link, say A is equal to 1 unit. Okay, we are assume that the link length of any one unit here initially start with the SOA. You are free to take any link, say ABCD, but here first point is A, so we are considered that A is equal to 1 unit. Okay, and we follow that formula for all the equations, that k1 is equal to d by a, or we can say that d is equal to, we are getting k1 into a, value of k1 we know 0.905 into a1, so we are getting 0.905 unit, that is the value of small d. Okay, now k2 is equal to d by c, or we can say that c is equal to d by k2. Okay, already we know the value of d, that is 0.905 unit, and the value of k2, as we have the value of k2, that is 1.01, so 1.01, so c is equal to 0.896 unit. Okay, so two values we are getting very easily. Now third value from the equation. What is the equation? We know very well. This is the first, this is the second, and third one, that is k3 equal to a square minus b square plus c square plus d square divided by 2ac. Okay, here if you see the value, then uh, b is the unknown for us, so we have put b on left side, so b square is equal to k3 into 2ac, right, minus in the bracket a square plus c square plus d square. Okay, okay, we want to find the value of b, so minus b square is equal to what happened, k3 2ac minus a square plus c square plus d square. Now we have put the value in the equation, that k3 is equal to 1.158 into 2 into AC. A is equal to 1, C is equal to, we are fine, that is 0.896. Okay, so same way a square, so 1 square plus c square, so 0.896 square plus d square means 0.905 unit. Okay, and if we solve this all, then we are getting the value of b is equal to 0.74 unit. Okay, 0.74 unit. So these are the answers of A, B, C, and D, as we assume that A is equal to 1 unit. So we are consider A is equal to 1 unit, or we are consider that capital AB is equal to 1 unit. After that, small b is equal to 74 unit, or we are consider that capital BC is equal to 70.74 units. Small c is equal to 0.896 unit, or we are consider that CD is equal to 0.896 and small d is equal to 0.905 unit, or we are consider that capital AD is equal to 0.905 unit. Okay, so these are the values we are getting for link length. Okay, so we have I just draw one uh, forward mechanism where AD is equal to 0.905. It is considered small d. We know that the theta means input angle is equal to 15 degree, and so at 15 degree I can get point B. At 15 degree I can get point D, and where AB, the value of AB is 1 unit, it is considered as small a. Okay, now we know the value of CD, that is 30 degree. So I am getting C point at 30 degree, and the answer of C is 0.896. So the length of this is 0.896. Join BC, where definitely BC equal to small b. So this is small a, this is small b, this is small c, and this is small d. Okay, this is the probable forward chain mechanism as per our notation. Okay, so same way you have to calculate for, you have to draw for 30 degree, and this is for 30 degrees, so input angle, and same way for 45 degrees. So you have to finish. If it may ask in your exam, then you have to draw all three positions of three input and three output, and finish the example in that way. So very easy problem, but probably, most probably it may ask in your exam.